Jai Hind. I am Dr. Sneha Mishra, Assistant Professor, Department of Computer Science and Engineering, AKGEC, Ghaziabad. We will be having lecture on machine learning techniques. So, the introductory topic will be the introduction of machine learning. It will be carrying the overview of machine learning, its types, historical context, and the learning problems for the students. So, first, before starting, we will have a definition of learning. So, what is learning? Learning is a process where system enhances performances through data experience similar to the human learning. And if we talk about machine learning, both humans and machines adapt learning from the observations only. So, highlighting it similarly with the learning, machine learning is making our devices, making our models more enhanced, enhancing their performances through the experience of the data is called machine learning. So, as example, house price prediction. In the house price prediction, a model predicts house prices by using historical data, learning factors like location and size of the house. So, house price can be predicted by having the historical data of that particular location, the size of the plots or the size of the houses, and based on that basis we can predict the house prices. Then comes self-driving cars. This is another example of machine learning only. In this, self-driving vehicles navigate by learning the sensor data or adjusting based on the prior experiences. Suppose if I am driving a car and the road is blocked, so again and again if 2 cars, 3 cars are passing from the same road, then we can consider from that the navigation should not go by that road. This is the type of self-driving cars learning. Then comparison with human learning. See, machine learning and human learning both are same and they adapt and learn from observations. So, in machine learning just we are enhancing the performances of the models, but in human learning, we are learning from our observations, we are learning from our habits. So, more or less they are similar to each other. Then we come to the learning approaches or the types of learnings. There are 4 types of learning. Basically, there are 3 types of learning: supervised, unsupervised and reinforcement learning. But there is one more, semi-supervised learning, which is the 4th category. In supervised learning, it involves the learning from the labeled data, where both input and output are known. For example, if we are training a model to classify the images of cats and dogs, this will be supervised learning. Why supervised learning? Because the data, the image data which we are providing as an input, it is already aware of that which image is of the cat or which image is of the dog. So, here if we are providing the data in the labeled form and after training our model with that particular data of cats and dogs, as an output, what we want to retrieve from that model? We want to retrieve that the data should be eligible in classifying the images of cats and dogs. So, supervised learning, what we did? We provided a labeled data to the model and that labeled data which was trained to the model, and as an output, what we receive? We are receiving the classified image of cats and dogs, such as supervised learning. Then comes unsupervised learning. What is unsupervised learning? It focuses on finding hidden patterns in data without the labeled outputs, such as customer segmentation based on purchasing behavior. So, unsupervised learning, I'll explain this example. Suppose I am a customer, I buy bread, and with bread, I also buy butter. So, it is a purchasing behavior that most of the customers which are buying bread, they are also buying butter with that. So, it is a pattern. With this hidden pattern, we are labeling our outputs. So, it focuses on the hidden patterns such as unsupervised learning. Then comes our reinforcement learning. In reinforcement learning, it learns through trials and errors by interacting with the environment, receiving rewards or penalties. It's used in training robots, game playing AI like AlphaGo, right? So, reinforcement learning is you have an agent, you also have an environment, and you are having rewards. Rewards may be positive and negative both. So it is used in training robots and game playing AIs. Then comes semi-supervised learning. So semi-supervised learning is the combination of labeled and unlabeled data for training, improving learning efficiency, such as, I'll give you an example, that is medical diagnosis system with limited laboratories, limited labeled cases. So what is it? Like we have medical diagnosis system. Suppose if I take the example of lung cancer detection. So in lung cancer detection, there will be the image of some X-ray, there may be some image of an MRI. So what we are doing is, we are having the data which may or may not be labeled. If it is not labeled, we are training our machine to train that data and label that data, and we are increasingly improving the efficiency and performance of the data. So this is semi-supervised learning, in which we are having labeled and unlabeled both type of data to train the model and improve the efficiency or improve the performance of the model, so that it can give good results in the testing. Now we'll go one by one with all types of learnings. Number one, that is supervised learning. So supervised learning is the type of machine learning where model is trained on labeled data, meaning that the data comes with input and output pairs, okay, features and labels both. So what are the key concepts of supervised learning? We will be having inputs. Inputs may be in the form of features or it may be in the form of labels. Outputs, it will be in the form of labels only, and the goal will be the mapping function or the prediction. Okay, so what is the input? Input is the data used to make predictions. It may be in the form of images, it may be in the form of text, it may be in the form of numbers. So output will be the model which tries to predict. It will be in the form of categories, it will be in the form of values. And goal will be the mapping function with the training data and the testing data. The mapping function, that what is the model predicting, the labels, right? So these are the key concepts of supervised learning. And how it works? First of all, the model is trained on the labeled examples. Once the model is trained, the model is tested on the unseen data, and then the model predicts the output of new inputs based on the learning patterns. So as of now, you must have learned that what is supervised learning. Yes, now comes what are the types of supervised learning. So there are two categories, classification and regression. In classification, we are just predicting the category. Like we talked about the example of cats and dogs. That was the image data in which we were doing classification. We were providing the input images and we were getting the output images as the classified images of cats and dogs. So that was the prediction of the category. Similarly, here is some other example, that is whether the mail is spam or not spam. So this is also the type of supervised learning where there is a label of the mail that it may be a spam mail or it may be a non-spam mail. So this is classification. Then what is regression? Another type of supervised learning is regression, in which we are predicting the continuous value. Like as example, we earlier discussed about the house price prediction. So when we are doing house price prediction, we are predicting the value of the house by various parameters, by comparing with the various parameters. So we are comparing with the continuous values. So regression is predicts the continuous value. If we take the example of classification, we want to predict whether the email is a spam or not spam. So input will be the words in the email, the sender's information. These will be the inputs. So inputs will be in the form of features, right? So by identifying the features, we will be able to identify whether the mail is a spam or not spam. So what will be the output? Output will be either the mail is spam or the mail is not spam. So maybe in 1 or 0 form, binary form, we can have the output, and the output will be received by us as a classified mails of whether they are spam or not spam, and the algorithms which will be working on it will be decision tree or logistic trees. Then we take this another example which will be telling about regression. So this example, in this we are predicting the house prices based on the features. So what will be the input here? Input will be the size of the house, the location of the house, number of bedrooms it is having, number of rooms it is having. Output will be the predicted price, and algorithm which will be working will be the linear regression. In our further lectures, we will be studying about these algorithms: decision tree, logistic regression, linear regression. These all the algorithms will be covered in future lectures. Now, real world applications of supervised learning. Yeah. Nowadays, speech recognition, converting the spoken words into text. We are classifying those spoken words into the text. So, speech recognition is the real world example of supervised learning. Then stock price prediction. It is also the estimating future stock prices. So, it is also the example of regression, and it is real world application of supervised learning. Then medical diagnosis. These are also used for classifying diseases based on symptoms. So, these are the real world applications of supervised learning. So, for now we have learned that supervised learning is powerful for making predictions when labeled data is available, and it is used to in many real world applications like fraud detection, image recognition, and the recommendation systems. So, these are the real world applications, and now we will move to unsupervised learning. So, what is unsupervised learning? Unsupervised learning is the type of machine learning where the models is trained on unlabeled data. In supervised learning, the models were trained on labeled data, but here the models are trained on unlabeled data. Unlike supervised learning, the model tries to find the patterns and structure in the data without any specific output label. As we discussed earlier, the example of customer prediction, like if the customer is buying bread, most of the time he or she is also buying butter. So, this is the type of a pattern that we are having. We can consider this pattern as a feature. So, the key concepts are the input data. Again, input data, here are features. The algorithm works only with input data which has no associated labels, and the goal is that the model's objective is to discover hidden patterns or grouping within the data. So, how it works? The algorithm analyzes the structure of data. Then it finds the pattern like grouping similar data points together or identifying frequent co-occurrences, and the model provides insights about the data such as forming the clusters, associations. So, now what are the types of unsupervised learning? It is like clustering and association. It is clustering. Clustering is grouping the data points into clusters based on the similarities. Like we did customer segmentation. In customer segmentation, what we did? We did clusters. We have made the cluster that if the customer is buying bread, it is buying butter, that is a type of a cluster we are making. They are having a same data points, right? And in association, what we are doing? We are identifying the relations between the data points. As example, market basket analysis, right? So, there are two types of unsupervised learning. One is clustering and another one is association. In clustering, what we are doing? We are grouping the customer based on their purchasing behavior. Suppose if the person is buying the particular brand, so we may consider that the person's income will be this. We may also consider the age of that person if the person is buying a similar type of data of the same age group. So, we are trying to find out the hidden patterns. So, first type is clustering, in which we are grouping the customers based on their purchasing behavior. So, input here as a feature will be their age, their income, their purchase history, and output will be in the form of segments of similar customers. As example, high spending, low spending, and the algorithms which will be working will be k-means clusters. Okay? Then example 2 will be the association, the next type of unsupervised learning, that is association. So, the example which we have taken here is, let's take the problem of identifying items frequently brought together in the store. This is the same example we are discussing in the whole video we have discussed. So here what will be the input? The input will be the items purchased in each transaction. And what will be the output? The relationships between items. As example, customers who buy bread often buy butter. So this is the relation between these two products. So here the input will be the feature like items purchased on each transaction, and output will be the relation between those items, right? And the algorithms which we generally use for association is a priori algorithm. And the real world examples of unsupervised learning are customer segmentation. In customer segmentation, what we are doing, we are grouping the customers for target marketing, and recommendation systems. We are also using unsupervised learning, like we are suggesting products based on users' behavior, and anomaly detection, in which we are detecting unusual patterns like fraud detection. I'll explain this example to you. What is anomaly detection? So what we are doing, suppose on an airport, we are having some unusual pattern. Some person has dropped his or her bag at some place and left the bag and went to somewhere else. So this can be the unusual behavior of that person, and that may be having explosives in that bag. So to prevent that, we have to detect the unusual patterns. So anomaly detection nowadays is a very real world application used for unsupervised learning. What are the key takeaways? Like unsupervised learning help discover hidden patterns in data without any labels, and it's widely used in areas like customer segmentation, market analysis, and also anomaly detection. Now comes the next part, that is reinforcement learning. So what is reinforcement learning? It is the type of machine learning where an agent learns to make decisions by interacting with the environment to achieve a specific goal. So here the agent is rewarded or penalized based on the actions it takes, and it learns to maximize the total reward over time. So what are the concepts here? There will be an agent, there must be an environment, there will be actions, rewards, and goals. So one by one we'll take all these key concepts. So first one, that is agent. Any learner, any decision maker is the agent. If we are talking about robot as reinforcement learning, then robot will be the agent. What will be the environment? Simulation will be the environment, game world will be the environment. If we are talking about the AI game players, then the game world, the simulation, these will be the environments, right? So everything the agent is interacting with is called as environment. What will be the actions? The actions will be whatever the choices the agent is making will be the actions, and rewards will be the feedback from the environment after an action. Rewards may be positive and negative both. And what will be the goals? The goals will be to maximize the cumulative reward by learning the best actions over time. So this is reinforcement learning. How it works? The agent first of all takes an action in the environment, then environment responds with the reward. Here you have to focus that the rewards may be positive and negative both in a new state, right? Then agent learns from this feedback to improve the future decisions, gradually learning the best strategy, which we call as policy. So here what is happening in reinforcement learning, the agent is communicating in the environment, whatever actions it is performing, it is getting the feedback or it is getting the rewards. In terms of rewards, it is improving its future decisions, and gradually it is the performing better performances, and the accuracy is increasing, and the robot or the game AI game which we are talking about, it is the enhanced version of itself. Here we take the example of game playing. So in game playing, the problem is training an AI to play chess. So agent will be the AI program. You must be aware of AlphaZero example, right? So agent will be the AI program. What will be the actions it will be taking? Actions will be moving the chess pieces, what all moves it has to make, those all will be the actions. What will be the environment? The chessboard will be the environment. And what will be the rewards? If it is winning, +1. If it is losing, -1. If it is a draw, then 0. So these are the rewards. See here, we can clearly see that the rewards may be positive and negative both. And what is the learning goal? The learning goal is to find the best strategy to win the game by maximizing rewards over time. So it was the best example of reinforcement learning, easy to understand. Then comes, what are the applications of reinforcement learning? So we can use it in robotics for teaching teaching robots to walk, grab some objects, to perform some tasks through trials and errors. Autonomous vehicles, like training the self-driving cars to navigate roads, avoid obstacles, and follow the traffic rules. We may also apply this in healthcare. So in healthcare, we can optimize the personalized treatments for patients by adjusting medications based on results. And also we can use it in recommendation systems to improve the recommendations by learning which suggestions users engage with the most. So here what we have learned till now about reinforcement learning is, it is ideal for tasks where agent can learn from its actions over time, and it's widely used in robotics, game AI, autonomous systems, optimizing real world decision making processes. So this is reinforcement. Now we come to the next topic, that is well-defined learning problem. We also call it as well-posed learning problems. So what is well-defined learning problem? Well-defined learning problem is a situation where learning process, objectives, outcomes are clearly specified. And in machine learning, we generally talk about the problems which are well-defined, right? So the components of well-defined problems are 3 components: TPE, task, performance measure, and experience. Basically, the task is what is the problem the model needs to solve. The performance is how we will evaluate the success, and experience is what data is used to learn. So this is the well-defined learning problem. Now we will explain one by one what is task, what is performance, and what is experience. So what is task? It is the it specifies what the model is being asked to do. It is its goal that learning algorithm tries to accomplish based on the input data. So task can vary for different problems, right? If we talk about the problem of classifying the mails as a spam and not spam, the task is different there. If we are talking about self-driving car, the task is different there. So the task can vary depending upon the nature of the problem. So now we have done the types of learning. The types of learning were supervised, unsupervised, and reinforcement learning. So in the next lecture, we will be continuing with the well-defined problem. Thank you.